Hi, everyone. So today we are with Rémi Canton, who is the head of Human Spaceflight Project at the French Space Agency CNES, and we asked him a few questions regarding the Alpha mission. So Rémi Canton, in your opinion, which experiment will lead to the most impressive results?
So we have a big ambition for all of them, and I cannot really predict what the results are going to be for each one. But I would like to talk to you specifically of one, which is called Pilote in French, or Pilot in English, which I think is interesting because it combines, it's a dual experiment that combines scientific interest with what we call tech demo, technological demonstrator, to prepare for exploration and the return to the moon. So I can get into a bit more details if you'd like. It's an experiment that combines virtual reality, which is very interesting for neuroscience, because you know the inner ear and your muscles, they don't give you the proper information once in microgravity, but your vision still can. So if you project the operator or the human subject in virtual reality, you totally control the visual inputs. And the astronauts will have to perform two virtual reality tasks, like video game, if you will, in which it will have to pilot first a drone, like a spaceship, if you want, through a tunnel or a corridor. And the second task will be to pilot a robotic arm to grab a space module, to grab it and to dock it to the space station. And the astronauts will do so with what we call a haptic device, which is sort of an elaborated joystick that's used sometimes in telemedicine, that gives you tactile information. You can feel the inertia of what you're moving, how hard it is, and really like a video game. If you touch something, it vibrates. So that's why it's a neuroscientific experiment, but dedicated to what we call telerobotic, like remote robotic control, because by the end of the decade, hopefully, we will have to pilot rovers on the lunar surface, for instance, but from lunar orbit. So the astronauts will be circling around the moon, and they will have to pilot virtually or remotely a rover on the ground. So by this pilot experiment, we learn a lot about how the brain functions to pilot different reference frame visually, and how the hand and the eye coordinate, the different control schemes you put into motion. And this will help us designing the control stations of the cockpits, if you will, to help controlling rovers on the lunar surface or Mars surface later.
Well, it sounds very interesting. And so if I well understood, it is also something that will advance telemedicine then.
Yeah, we hope so, because by learning how the brain processes visual information, tactile information, and in a very particular environment, which is microgravity, where dexterity is really affected. You don't feel the weight of your arm, of your body, and so the brain really has to adapt, and you learn a lot. This is the kind of experiment where you learn a lot about the inner functioning of the brain, of what we call the central nervous system. So the application is knowledge on the brain, again, is neuroscience, and one application is telemedicine. That's a very important hope that we have in this experiment, on top of the practical space applications.
Well, thank you very much, Rémi Canton. So we are looking forward to see what are the next developments in the next few months. And well, I guess see you soon.
Yes, thank you. It's already just one thing. It's really it's starting to be a big success, because Thomas Pesquet already performed it. His first run is going to do several different sequences. He did 2 weeks ago. He did the first run of the pilot experiment, and he liked it so much that he convinced another astronaut who is on board with him, the American astronaut, to perform it. So we have 2 subjects, even though Thomas was the only one targeted initially. So we have 2 data points, which is important for us.
Well, that's another good.
MacArthur.
All right. Thank you so much, Rémi Canton.
Thank you, Risa. Have a good day.